Welcome to BKW Physics. I'm Mr. McConley, and today we're going to follow up yesterday's lesson with Newton's second law. So, his first law, just to recap what we already know, his first law said objects have inertia, and what inertia is based on is, what's the key word?
Mass.
Mass. Thank you. Guys are paying attention. The more mass you have, the more inertia you have. If you have a lot of inertia, you want to stay at rest if you're already at a rest. If you have a lot of inertia and you're moving, you want to keep moving because your mass makes it so that you want to keep doing the same thing. Well, switching gears up to the second law says this. An unbalanced net force acts on an object and causes an acceleration which is directly proportional to the force and in the direction of the force. And first of all, let's pull out some key things. If you're trying to pull out the two key words here, a few key words, net force and acceleration. Net force causes acceleration. That is the key to his second law. The direction will come into play when I show a demonstration in a day or two, and we'll get back to that concept. But for right now, just you got a net force and an acceleration. What's a net force? Because a force is a push or a pull, but what is a net force? Well, most every example that you can think of, even if I say, okay, I got a lunchbox here, I'm going to push on this lunchbox. So you think, well, that's just a force. Yeah, but if it were just me pushing, it would push a lot easier. It doesn't seem to slide across my hand that easily, because what's the other force that you're kind of ignoring? Friction. So there's actually a couple forces to play here. Say the friction is 2 in this direction, and say I'm pushing 7 in this direction. What's the net force? 5 in that direction. Okay? So that's why we say net force, because there's usually a couple little forces, and you got to kind of add them up and take into account the direction they're pointing. Anyhow, eventually we get to the idea that the equation is A equals F net over M. That's acceleration equals the net force divided by the mass. Mass is in kilograms, as we've come to expect in this class. Because it's not that grams are terrible, it's just that usually you're dealing with things that are pretty large numbers, so the gram number would be so big it's easier to deal with the kilograms because it shortens the number up. F net is the sum total of all the forces. Forces are in newtons. And acceleration is in meters per second, or meters per second squared. So I gave you a little example. It'll be real quick here. We've talked about these sprint cars before. Here's a picture of one. He must have throttled it up a lot, so it pulled the front wheels off the ground. It's pretty cool. And what is the net force required if this 690 kilogram sprint car is accelerating at, we'll call it 1g, 10 meters per second squared, because it's basically real close to 1g. So,
6,900.
and how'd you get that? Well, all he did is he said, okay, I know that acceleration is F net over M, but he kind of rearranges it in his head. He says, okay, the net force is mass times acceleration. The mass is 690. The acceleration is 10, multiplying 6,900. Thank you. So that's exactly what you do, and this is just a simple example of how this works. Now, at the bottom of this page, this is for the people that are watching the video. If you go to this website right here, on YouTube, it's a video, and it's of Felix Baumgartner jumping out of a little, I don't know what you want to call it, balloon type of thing from outer space and then falling. And it gives you just one more example of Newton's second law. What's the force he was experiencing? What does the force come from that pulls Felix Baumgartner down?
Gravity.
Gravity, the force of gravity. Is he getting any friction?
No,
Well, not at first, until he gets into the atmosphere, and then he actually does. So as the problem continues, the situation evolves, and it actually goes from just being one force to a couple forces. So it's actually a complex problem figuring out what happens when you jump out of something from that altitude. So for today, Newton's second law, physics.